Moving on to the configuration, I would say that probably the most important thing you will have to do on the device to prepare it for SSL policy is going to be to deal with the right certificates. So this is something that you will have to do under objects, object management, and PKI. In case of the decrypt resign rules, if you plan to have some of those, so again, this is for the communication that is sent to external servers that you want to decrypt, to websites hosted by your partners or simply websites connected to the internet. In this case, we will have to add a FTD certificate to the internal CA. Okay, the second case, so when you want to use the known key decryption, the website certificate and the private key, you will want to put it to the internal certificate PKI object. If we take a look at that on our device, I'm going to go to Objects, Object Management, and then PKI. There are going to be a few more places related to the PKI objects on FTD. Let's look at those as well. So we have actually 1, 2, 3, 4, insert enrollment. We have 5 different places related to certificates on FTD. Okay, whenever it says CA, of course, this is talking about the certificates of the CAs. And we have internal, which is going to be our CAs. We're trusted. This is talking about the public CAs. Now for the search options, external and internal, this is talking about the endpoint certificates, identity certificates, like FTD certificate or certificate of our server. So internal is for our certificates versus external is for certificates of the endpoints that are not managed by our organization, outside of our organization. And there is also this certificate enrollment option. This is something that you would use to enroll for a certificate for virtual private network authentication. Like if you want to do site-to-site, let's say VPN with a certificate authentication. Okay, so I would start with this config, and we will actually go to the internal CA, because during the demonstration, I will want to show you how to decrypt communication using the resign action. So we will want to resign certificate, which is going to be presented by router 1. This device is going to act as a HTTPS server. And we will use a PC, which is going to be 10.11.11.200 as a web client. So we will be connecting from the inside of the FTD through the outside up to this web server. So this is going to be the external content hosted on an external web server. We will have to use the resign action to decrypt this flow, which means that I will have to install FTD's certificate to be able to use this certificate to decrypt this communication in the proxy mode. Okay, so we go to the internal CAs. I'm going to use a self-signed certificate. Of course, this is going to be the easiest option to use. I'm going to call it FTD1 INE say.com. So US, state, city, organization, and department is going to be security. Common name, I'm going to copy this, so paste over here. We'll generate self-signed CA. Okay, so self-signed certificate, it means that this CA issued a certificate for itself. Okay, moving on, the other two things that we will have to do. One of them, of course, is going to be to build and create a new SSL policy and populate it with some roles, at least one. And to finish this config, we will have to activate our SSL policy in the HCP. Let's take a look at this. I'm going to show you a simple configuration. But first, we will go to the policies, access control, and then SSL. I'm going to add a new SSL policy. SSL policy FTD 1. The default action is going to be to not perform decryption. The default action is acting as a catch-all in the policy, the last rule, similar to block in the HCP. We will now edit this policy because we want to add at least one rule. Okay, a single rule I'm going to add. I'm going to call it out www. It's going to be from the inside to the outside. And we will be looking at HTTPS traffic. So all encrypted web sessions outbound. The action I'm going to set to decrypt resign. And we will choose the FTD's self-signed certificate. Okay, the rule is enabled. In terms of the other options that you could use as you build the rules, you could of course refer to individual IP addresses or groups of IP addresses. VLAN tags, this is for layer 2. User information can be also included if you integrated your device with Active Directory. We can refer to applications based on the risk, business relevance, types, and categories. Of course, we can select individual protocols and ports. We can choose URL categories. We could choose one of the available certificates. This stuff, maybe let's quickly take a look at this in the documentation. It's going to be under encrypted traffic handling. We will take a look at, maybe let's take a look at get started with TLS SSL rules. Let's take a look at conditions. Certificates. It says by the server certificate used to negotiate the encrypted session. You can control encrypted traffic based on the server certificate passed to the user's browser in order to negotiate the encrypted session. So we can select the certificate of the server as one of the conditions. Distinguish name. This is another portion related to the certificate itself. We can choose the traffic based on the CA that issued a certificate or based on the subject. We have certificate status, such as revoked, valid, like self-signed, expired, server mismatch. So you can play with those. Instead of using any, you can use, let's say, self-signed. If you want to build a rule for websites that are protected with self-signed certificates, you would choose yes for self-signed. We can take a look at the session parameters negotiated, like cipher suites, and then the version. Okay, logging. You can log this traffic if you want. We will not be using logging here in this example. I'm going to add, and we will also take a look at undecryptable actions. The default action configured in the policy is to not decrypt. But there is also a concept of undecryptable actions, which is related to traffic that FTD cannot decrypt. So as you can see, for most of them, by default, it's going to take the default action, which is once again to not decrypt. But you can change this. For instance, if you want to drop all compressed SSL sessions, you would choose block over here. SSL version 2 sessions are deemed as undecryptable. You can tell what you want to do with them over here. Same for unknown cipher suites, unsupported cipher suites, sessions that are not cached, handshake errors, and other decryption errors. Okay, I'm gonna save our simple policy. And now the last step that you will have to do is gonna be to activate it in the ACP. Now in the ACP itself, we will also have to have a role that will allow traffic to go out, because with access control policy blocking, the decrypted traffic is gonna hit the default rule. So I will add a simple rule where I'm gonna tell it that I'm okay with all inside to outside communication. Okay, so this is so we can eventually get to the server. Because remember, decrypted traffic is still subject to the ACP. We will deploy. And maybe quickly before the config gets to the device, let's go to the PC and let's try to, actually in this case the ACP is blocking this traffic, so I won't be able to show you that we will get to the server 11.1.1.1. We need to wait for the policy to be pushed. Okay, so we will take a look at what's gonna, how is the certificate gonna look like after the decryption takes place. Right, it looks that we can now take a look at the PC once again. We will try to connect one more time, and we see that it complains about the not secure connection. It's all about the certificate of the server, which is not trusted. So I'm gonna say we wanna add an exception. I will confirm. We see that we connected to the router, which is emulating our web server. But one thing I want to take a look at, let's say cancel. I want to take a look at the certificate details. I'm going to say view certificate. And it says that the common name equals the issuer name, which is the iOS self-signed certificate. And this is the correct behavior for this session as of right now, because I forgot to activate the SSL policy. So this is what I wanted to show you in the first place. Even that I pushed the policy to the FTD, I didn't activate it under SSL policy. So decryption is not taking place as of right now. We just allow the traffic based on rule number 3, and this is encrypted communication. So we build the SSL TLS tunnel with the server itself. When we now modify this policy and select our custom SSL policy, deploy this change, as we connect for the second time, the result should be different. We can go to the analysis connection events. Let me close the browser to clear the cache. And on the connection events, we will take a look at more details in the table view. So we shouldn't see any decryption taking place as of right now. Okay, those block actions here, this is what's left after I was trying to connect from the PC before deploying the policy. So this is the default role that was blocking it. We don't see any interface as of right now because we haven't enabled logging on the role from the inside to the outside. But we see that it doesn't say anything about the decryption. So no decryption took place. We just allowed encrypted traffic through the FTD, which is not logged. And that's fine. Now with the new policy in place, which is our activated SSL policy, we should see a difference. We go back to the PC and we will try to connect to the server once again. It says invalid certificate, unknown issuer. So we have to add the exception for the second time. I'm gonna confirm. Okay, we see we have connectivity like in the previous case, but what is gonna change is that if we take a look at the certificate once again, this time the certificate is different. We see that it is issued by FTD, by our Firepower Threat Defense device, to the server. So the subject is, the issuer is FTD. The subject is of course the same, it's the server. Based on this information, we know that decryption took place. And if we take a look at that in the connection viewer, the difference is that it is gonna inform us about the decryption. Well, I believe that the logging is gonna be enabled for this by default. No, it is not. We don't see anything here because we didn't enable logging in the SSL policy. So this is gonna be the last thing that we will fix. We will go back to the SSL policy, adjust the role. But again, this information, the certificate alone, is a 100% indication that decryption took place. If you want to double check this, you could enable logging in this role. Forgot to do this. Okay, so we will send this to the event viewer. We will redeploy. I just need to save this config first. We go back to the connection events. On the PC, I'm gonna refresh this website. So we reconnect. And then let's also refresh connection events. So logging is something that I would use as a final verification tool. We see those 3 additional entries now. And under SSL status, the decrypt resign message confirms that decryption in fact took place.